after that, we'll go up to the top floor, check out the production of the power plant itself. And then after that, we'll go into the meeting room. And I will give you like a presentation from the slides, and we'll have some coffee. Sounds good? Yes, very good. Then you can just start. Yeah. So Iceland. Wait, maybe a first question for you. Have you had any introduction to the geology of the island?
Yes, we had some yesterday.
Some? Yeah? Okay.
Some during the presentation of a project partner
Yes.
to the National Energy Organization.
Yes, okay.
Outside the capital, Reykjavik.
Okay, very good. Then I will still do this.
Okay, that's good.
Okay, so Iceland. Iceland is a young island, geologically speaking, in that way that the oldest rock here in Iceland is roughly 16.5 million years old here in the West Coast. But we also have one of the oldest rocks here in the Eastlands. Why that is of course because of this orange line that goes straight through the entire island. This orange line is called the Mid-Atlantic Oceanic Ridge. The Mid-Atlantic Oceanic Ridge extends throughout the whole Atlantic Ocean. It's roughly in the middle of it, so the name is also really good. And that is a plate boundary between the two tectonic plates that we have. We have the North American tectonic plate over here in the west, and then of course the Eurasian tectonic plate over here in the east. This is a divergent plate boundary, meaning that these two tectonic plates, they are separating from each other. The separation is approximately 2 centimeters per year on average for the entire island. But as you can see from this map, this plate boundary does not explain why Iceland exists in the first place. Otherwise, Iceland would just be dominating the whole Atlantic Ocean over here. Why Iceland exists in the first place is because of this thing over here. This thing represents a hot spot. A hot spot is the surface manifestation of a mantle plume. You can imagine a column of really hot magma material coming from really deep down from the earth, driving this hot magma material to the surface of the earth, and therefore forming the island Iceland. Maybe a quick question for you. Do you know any other famous hotspots?
Vesuvius.
You can say that, for example, Hawaii is a hotspot.
Yes.
Yeah? And if we take Hawaii, for example, the Hawaiian hotspot is located roughly in the middle of the Pacific plate. And the theory is for hotspots is that they stay in the same place and the tectonic plates move above them. This is why, for example, in Hawaii, it forms like a chain of islands. But here in Iceland, we have both the separation of the tectonic plates and the hotspot happening at the same time. So this is why we have the big whole island Iceland instead of an island chain. Now in Iceland, depending on your definition, but in my definition, we have about 33 active volcanic systems. These 33 active volcanic systems are mostly following this plate boundary over here. The most recent volcanic eruption that we had was, or is still going here on the Reykjanes Peninsula, and we will probably see a lot of seismic and volcanic activity in that area for the next foreseeable future. Some of you might remember also this one over here, Eyjafjallajökull, that erupted in 2010. Do you remember that? It erupted under a glacier, so it spewed a lot of ash and tephra into the atmosphere. So a lot of planes, yeah, exactly. There were a lot of planes grounded during this volcanic eruption. But we are also standing in one of the active volcanic systems right now. And this is called the Hengill volcanic system. The Hengill volcanic system last erupted around 2,000 years ago. But this volcanic system also holds what we call a high temperature geothermal system. Now, for a high temperature geothermal system to form, we essentially need to have three things to be present. First, we need to have permeable bedrock formations, like the basaltic rock that is everywhere around Iceland. Then we need to have a lot of water, and then we need to have the heat source. The heat source is, of course, the active volcanic system that we have. So the water will seep into these permeable bedrock formations, gets heated up by the heat source, forms this high temperature geothermal system, and then we can utilize that with our geothermal power plants. But outside of these active volcanic systems, we have what we call low temperature geothermal systems. And the definition between these two geothermal systems is that at 1 kilometer depth for the low temperature, we have temperatures ranging from 30 degrees Celsius to about 150 degrees Celsius. Then for the high temperature at the same depth, 1 kilometer, then we have temperatures of 200 degrees Celsius and above. This is like the technical definition between these two geothermal systems. But maybe like a more clearer thing is that if you drill into the low temperature over here, what you can extract is hot water only. But if you drill into the high temperature, what you can extract is a combination of hot water and steam. This is why we can have electricity production here at this point. Now, we have 7 of these kind of geothermal power plants here in Iceland. There are 4 located here in the southwest, and there are 3 up here in the north. These 7 geothermal power plants make up around 30% of the total electricity produced in Iceland. The other 70% comes from hydroelectric power plants, rivers and dams and such. Add these two numbers together to get 100% renewable energy for the entire national grid of Iceland, which is incredible. We have 2 wind turbines for the entire island. They are from the National Power Company, located somewhere here in the highlands, kind of. They are like experimental wind turbines. And on what we call the master plan, or rammaáætlun in Icelandic, the master plan goes into depth on where we can have the next power plants, whether that is hydro, geothermal, or even wind. And on the table right now are 2 wind farms somewhere in the highlands from the National Power Company. But we'll see how that develops in the coming years. The national grid, where all power plants exceeding 5 megawatts are connected to. And the national grid extends throughout the whole island. So most of the population in Iceland is connected to electricity. Here at this facility we are producing 2 things. We are producing electricity and hot water. Now, most of the heating done here in Iceland is from geothermal, meaning that we are utilizing these low temperature areas around the entire island. You can see that the capital area is over here, where most of the population lives, and we are located over here. Here at this facility we are always producing hot water for the capital area, but over the winter time, for example, we utilize these low temperature areas inside the capital. But over the summertime we try to rest them, and so they can replenish naturally, and then we can utilize them fully over the winter time. Alright, any questions about geology or something like that?
So you use hydropower in order to produce energy, and geothermal pumps in order to produce hot water for use. This is what you said?
Yeah, I mean, most of the electricity, yes, is generated with hydroelectric power plants, yes, but 30% is also from these geothermal power plants that are both producing electricity and hot water. But yes, we are using these low temperature for heating. For example, if you live here in this part over here, there's no geothermal power plant nearby you, so you can just drill a hole into the earth and extract the hot water directly from the earth.
Okay, thank you.
Yes, more questions? Good, okay. Let's then go up to the top floor, check out the production of the power plant itself. There are elevators on either sides of the stairs. They really are good, yeah. Alright, so for the production of the power plant, as you can see, we need to drill 3 separate times into the bedrock. And the first type of drilling that we do is this one here in the middle. This is called the production borehole. The production borehole goes to an average depth of about 2 kilometers, or 1.2 miles into the bedrock. At this depth, we have temperatures at about 300 degrees Celsius. It's fairly hot down there. And what we are extracting from each individual borehole is what we call the geothermal fluid. This geothermal fluid is still in liquid form down at this depth because of the pressure from the surrounding bedrock that's pushing down on it and therefore keeping it in liquid state. But then we drill down into it, extract it to the surface of the earth and therefore lower the pressure. And then it becomes a combination of both steam and geothermal fluid together. And because we get both of them in the same pipeline, we need to separate them from each other because we want to use them independently. The big tanks that you can see here on your left-hand side, these are called the separation tanks. Separation tanks are horizontal gravity based. In that way that the steam wants to go up, fluid wants to go down. So we separate them with gravity. After the separation states, the steam goes into the inlet pipeline and into our turbines. And we have 6 high-pressure turbines and 1 low-pressure turbine with a combined power output of 303 megawatts of electricity. At the back of the turbine, we have what we call a condensing unit, meaning that the steam will either condense back into water or will be released into the atmosphere through the cooling tower system itself. Now for the hot water production here at this facility, that is a little bit different because we cannot really use this geothermal fluid directly. This geothermal fluid is water with a lot of dissolved minerals inside of it, for example silica. And if we were to send this silica-rich fluid directly through the pipelines of the homes, which are just incredibly small, we would just clog them up eventually and we could not use them anymore. So what we do is that we take out fresh cold groundwater from a nearby vicinity of the power plant, put that into parallel pipes with this geothermal fluid, and we do like a heat exchange between the two. We're heating up the groundwater with the geothermal fluid. Then we can send this hot groundwater into the distribution center in the capital area, and then we can distribute this hot groundwater into each individual home, and then we can utilize that by either turning on our radiators or just the tap water system itself. After the hot water has gone through the radiator, it goes into the runoff pipeline, and from the runoff pipeline it goes into the ocean. We have used this geothermal fluid for the heat exchanging purposes, but we need to get rid of that somehow, and we do that by simply, as you can see, re-inject it back into the ground. Therefore, we help nature with this renewable energy aspect of this power. Here at this facility, if we think of the reservoir as about 100%, and the re-injection fluid is about 80%. We are roughly 80% efficient in re-injecting the fluid back into it. That is very, very good for a geothermal power plant. And then the production wells are up inside the mountain, and all of the re-injection wells are here on the front of the power plant. And so there is like a dispersion between them. But if we have done tracer tests, for example, and some of the geothermal fluid has percolated into the production wells in about 2 weeks, but some of them take about 6 months. So there is like where we have the re-injection boreholes, and you just have to mix them together. All right, questions? Since this facility is up in the mountain, most of the hot water or heated up groundwater is just gravity fed.
Πώς μπορεί να έχει 300 βαθμούς Κελσίου νερό, είναι δυνατόν? 300 βαθμούς Κελσίου νερό είναι δυνατόν να έχει? Steam, σκέτο steam.
No, the hot water goes through the radiators and then it goes into the ocean.
Magnum που είπε, το Magnum. Είναι το μάγμα.
Και αυτό το βάζουν στη σαρπαντίνα για να ζεστάνουν το
this groundwater is just from groundwater boreholes just right over here, like 2 kilometers away. And we drill down to roughly 200-250 meter depth for the groundwater reservoir, and then we can just
Σε αυτό εδώ το διαχωρίζουμε παίρνουν νητρό.
Ναι.
Εδώ, σε αυτά εδώ, στην κάτω πλευρά, είδες με το βάρη.
Ναι, διαχωρισμό.
That is the thing. The question was also, are we going to deplete the system? So, I mean, for example, with the production, geothermal power plants have a lifespan of about 50 years. That is like the rule of thumb.